So here we have a parametric function described in terms of sine and sine t and sine 2t, and we're being asked firstly to find the Cartesian equation. So we know if this was a non-trig example, we'd be looking to rewrite one equation as t equals and substitute that in. As soon as we've got trig, we can't. Instead, we're looking for an identity which involves the two things that we've got in our two functions. And I guess there's good news here because we've only got one identity that involves sine 2x or sine 2t in this case. The other thing I'll note is we've got a range of values here which is identical to the range of values we talked about just a moment ago, from minus 90 to plus 90. It's given in terms of radians. Parametric equations nearly always are in terms of radians because very often questions involve differentiating the parametric function, and you may remember me telling you that when you differentiate sine, cos, tan, anything trigonometric, you have to be working in radians. It doesn't work in radians. So write down the identity for sine 2t, and then thinking about what we perhaps did in the start. So see if you can get somewhere with part A. And I'm sorry if I didn't start recording during the starter, so there you go. So I've got something for sine t, that's just x. I haven't got something for cos t, except I can write it in terms of sine. So I'm just going to replace sine t with x. And I'm going to replace sine 2t with y. So that's y, that's 2 lots of x. And this is the square root of 1 minus x squared. Okay? If x is sine t, then sine squared t is x squared. So that's end of the question. End of the question. We're asked then about the range of this function. So, we could, if we knew how to sketch this, we could work out, but we've got to be careful because although it's this function, it's only this function for selected values. So it's much easier to look at your parametric equations. The domain are the numbers I'm allowed to put in, and for that we would look at the x equals, so I'd look at that. We're not asked about the domain. The range is about the y values. And I've got to look at sine 2t. So let's sketch a full sine curve to start with, perhaps going backwards a little bit negative. If you replace t with 2t, it's squeezed in. So what I'm going to get is something like that. we're dealing between minus 90 and plus 90, so my y values will be everything between 1 and minus 1. So the range is that. So, and you've always got the check. Your calculator will do it. You could plot this as a parametric function. It's a bit fiddly. You've got to set the t values. You have to go to Shift V window and everything. But you could then use your calculator to check that you've got that range correct. Right, that's the first of the two examples. The second is... So they give us a bit of a clue here and say this is a circle. And we've got sine in one and cos in the other. So the identity I need here is the identity that links sine and cos. Not sine over cos is tan, because there's no tan involved here. But I do know that sine squared plus cos squared equals 1. So you've got to rearrange both equations, one as sine equals and the other as cos equals, and substitute it into here. And then it's about remembering our circle theory stuff from last year. See how you can see if you can remember how you work out the radius and centre when you've got the equation of a circle. That's a good revision. If you don't fiddle with your pen, it doesn't blow up. Only when you start fiddling with it, and things like that. So I get that, I rewrite the x parametric equation in terms of sine t. Sine t is x plus 5. Similarly for the y equals, and then I just sub it in. So can we remember what the centre of this circle is? Seb, what's the centre of this circle going to be?
Minus 5, 2.
Fantastic, yeah. So the centre of the circle is minus 5, 2. Remember, this is the radius squared, so it's radius 1. Simple as. And the domain, so those are the numbers you put in. So we basically need, do you remember we said my interview question, we basically need sine to go through its full range of values in order to draw this as a circle. So t just needs to be between 0 and pi over 2. Although if it was more than that, you would just be drawing the same circle more than once. So, but that's okay. Both of those domain and range questions, in the one in the previous question and this one, says write down. So if it's write down, it should be something obvious. So that's always a bit of a hint that there's something obvious going on. Sometimes it says state instead. They're saying we really don't need to do any sums here. It should be something obvious. Right, so high time I shut up and you did some practice. So on page 204, exercise 8b. I'm proposing question 1, or there's several bits to question 1, so you may get bored, or it's excellent practice because each question will involve a different identity. So you're dragging the identities out, and there's 3, 4, and 6. 6 is quite a nice meaty question that I've pre-prepared, so I don't get caught out. I invite you to have a go at those, and we'll pause every now and then just to discuss them. Yeah, I think 1b, there's a misprint in the range of values for t. I think it should be from 0 to pi. And I'm suggesting we do 1a, b, c, and then jump to 3, 4, and then 6. So this one was very much like the circle one, although that's not strictly a circle, but it will be something loopy. Rearrange both as sine and cos, subbed it in. This is sine 2t is always a bit fiddly because you've got to make sine and cos, and we've only got cos, so we have to make sine doing the whole identity thing. But c, although normally cos 2, it's a pain that there's so many cos 2x identities. It's really useful here because there's definitely one that only involves cos. So see if you could either look it up or recall it. Good practice. It's not essential that Cartesian's written as y equals, clearly, but yeah, so with that one, cos 2t was y over 2. So y over 2 was equal to 1 minus cos squared, was equal to 2 cos squared minus 1, which is 2x squared minus 1. And I then just doubled through everything. I'll be interested to know what they did. Don't leave it as... They doubled through everything as well. Oh, and actually, yeah, that's interesting. So they multiplied that one out. So they multiplied, so you've got x minus 1 squared over 4, y minus 4 squared over 25, then they multiplied by 100. So same thing. Question 3 after that. So it's another circle one. So sine is y minus 3. So that's y minus 3. Y minus 3 squared, and cos is x plus 2. So just got to make sure we don't get caught out there. It's the opposite of that, and the same. So opposite of that, and the same. Opposite of that with the centre, and the radius is 1. But maybe we were just a little bit thrown by the range of values being slightly different. We know with 0 to 2 pi, we get the full circle. What about if you go from minus pi to plus pi? I mean, maybe you weren't confused, which is brilliant. But if you were, then we've got the calculator to help us out, haven't we? So I can type in. I don't know. I think I was being over careful with the brackets. I didn't want it to do the cos of t minus 2. So I'm assuming, did someone do it without brackets and it worked fine? I think I'm being overcautious there. Remember then the key thing, Shift V window. Firstly, I was in radians. So I went, I thought I'd change that, sorry. So let's do it then. From minus pi to pi. Now you've got to be careful with your pitch. If you're in degrees, minus 180 to plus 180, you had a pitch of that, that's going to take 20 data points for each degree, so that's 360 times 20, it would take forever. So now I'm only going from minus 3 to plus 3. It's like the step when you're using the table function. So I'm going to put 0.1 just so I get a nice curve that's got plenty of points. You still get the full circle, and that's because we're still doing a full 360 degrees, although it's from minus 180 to plus 180. We're using a full range of values here as t, so we get a full range of values for both sine and cos, and that's why we get the circle we expected. So it's a circle with a centre minus 2, 3, and a radius of 1. Question 3, I skipped through, but hopefully you were okay with that one. Yeah, they very often hook this together with circle geometry. So, you know, again, that's an example of a question where you can get 2 topics for the price of 1. And then question 6, forgive me if, yes, sorry, Hannah.
Sorry, I'm just a little bit confused about question 3.
Yes?
How do you get from, well, because I got in, like, fractions in the
Okay,
brackets.
yes. I'm very glad you've raised that point, because I should have made that point, shouldn't I? So let me go through that one. So we've got x minus 3 is 4 sine t. So that means sine t is x minus 3 over 4. Yep. And y plus 1 is 4 cos t. So y plus 1 over 4 is cos t. Right, so now if we substitute that into sine squared plus cos squared is 1, we've got that squared plus that squared equals 1. But I can square a fraction by just squaring the numerator and squaring the denominator. But no, well, I should have made the point because it's not immediately obvious. And then multiplied through by 16.
Yeah.
So that's why we got, the centre was 3 minus 1 and the radius was 4. Thank you so much for asking. Just very quickly with 6, I've left myself enough time. It's really tempting to think this has got to be a really complicated identity, sec squared. It's going to be one of those Pythagorean ones. But actually, sec squared is 1 over cos squared. So y is a quarter of sec squared, so that means sec squared is 4y, so that's 4y, and cos is x over 8, so that's squared, 1 over cos squared. And I know that 1 over a fraction is that fraction just flipped. So I've got 4y is 64 over x squared. So that means that y is 16 over x squared. Y is 16 over x squared. The graph of 1 over x squared looks like that. 16 over x squared looks like the same shape. We're only dealing with positive values. I didn't leave enough time, I apologise. So that's why it is like that. Good stuff. I've set you more uplearn for the weekend, but no submission question because it's Christmas. But let's try and get finished by the end of next week. I have no intention of setting you upload over Christmas. None whatsoever. I may give you a revision list, but you've got plenty of time after Christmas if you choose to leave it. Give yourself a break.